In this part of the introductory property maths exercise, we're going to apply these Excel financial functions to a very common question in property investment financing, and that's the question of working with loan calculations or mortgage calculations. We're going to be looking at a credit foncia loan, which is a fancy name for your typical mortgage where you're paying off interest and principal over a period of time. We're really looking at practicing our application skills of financial mathematics using Excel, and we're going to really demonstrate also how these self-correcting exercises work. And they work by starting off with a yellow highlighted cell which is waiting for you to put an answer in it, and it's only when you put the correct answer, usually in the form of an equation, that the yellow highlight will disappear. And once the yellow highlight disappears, that tells you that you've actually put the correct equation in, and then you can use that equation embedded in the model we're building for any other set of data entered as the numbers or the quantities in the blue fonts. In presenting this exercise, I was originally going to completely re-record the original presentation I did, which is now getting to be a couple of years ago. And when I looked over the original recording, I thought, well, the mathematics hasn't changed. The model works extremely well and has been popular with students over the last few years. What can I really change to improve it? And apart from the fact that I now have grown a beard, everything else is identical. And so for the moment, I'm going to now switch back to the original recording. As I say, it was done a few years ago, but this is still absolutely leading edge calculations. In fact, if you master not just the concepts but also the modelling in this exercise, you'll find that you'll be able to advise people on the management of their home mortgages, probably better than many other practitioners, both in the investment advice area and in the valuation advice, and just generally to have a beer with your mates and give them a few clues as to how to manage their property acquisitions. So it's a very useful tool. We'll actually be even doing a more elaborate version of this in a few weeks' time. But this one gets us started with the modelling exercises, the modelling functions, and how to work this up in Excel. So without further explanation, I will hand over now to an earlier version of me who presented this material, which is still most relevant. And I suspect the models you'll build in this exercise you will probably use for many years to come in your professional lives.
We're going to be looking at loan calculations related to a fairly typical mortgage. So this could be a home mortgage. We're looking at something which is having a term of 25 years, in other words, 25 years to pay it off. We've borrowed $350,000 known as the principal. That also is the present value of the loan. When you think about it, you receive $350,000, so that's a cash flow in one direction, and then you pay that off for the next 25 years with cash flows in the other direction. So you can model that using the kind of up and down arrows that we used in the previous page. There is an interest rate, which for our purposes will be the discount rate. So the interest rate of 12% we use as the discount rate, the time value of money. And that's basically what we're going to be modelling. Later on, as we get down to the bottom of the exercise, we'll introduce this last parameter, but I won't confuse things by talking about it now. The first thing we notice about home mortgages is that even though they're worked out in annual terms, a 25-year loan and a 12% per annum interest rate, we actually encounter the loan on a month-by-month basis. So we need to convert the annual amounts down to monthly amounts. So how many monthly payments are there? Well, it's going to be quite simple. It's going to be 25 times 12. So here we simply point and click to go at the 25. Going to multiply that with a star times 12 gives you the answer. The nice thing about writing it out in this form as an equation rather than simply writing out 300, which is fairly easy to calculate in your head, is that if the 25 years becomes 20 or 30, then that number will automatically change. And this is generally what I'd like you to practice doing as you build these models. Don't put numbers in, put equations. And that way, as you change the blue numbers, the rest of this stuff will follow suit. Next thing we want to look at is the monthly interest rate. I'd like you to do the calculation for that yourself. I might just talk and prattle on for a bit. In fact, I'll come down to this next one. I'll let you work out that equation. Then I'll put it in myself. Not really a trick question. It's the annual interest rate. Bingo, 1% per month. Not hard at all. The next cell, the next equation to write is the one where I get to use the fancy Excel functions. In this case, I'm looking for repayments, so I'm using the Excel PMT function. So I'll go equals, key equals, PMT, open brackets. The rate is the monthly interest rate I've calculated. The number of periods is the 300. And the PV, this is a tiny little bit tricky because I'll put a negative sign in to keep the sign conventions in Excel working correctly. Not a big deal, but it's just useful to put those in because that gives me a positive answer here. Okay, so what that's telling us is that if I borrow $350,000 over 25 years at 12%, I'm going to be repaying with monthly payments of $3,686 per month. What's my total repayment? Total repayment is simply 300 times the monthly repayment. And so the calculation here, there's no built-in function for it because it's so easy to calculate by hand. I'm paying back $1.1 million on my $350,000 loan. Total interest is worth thinking about. Give some thought while I'm talking to you as to what it is. Some of you might be able to write this equation in before I even tell you what the answer is. It's very simply the difference between the total repayments and the original amount borrowed. And there we have it. About $750,000 of pure interest in order to have the pleasure of using $350,000. So about twice as much interest as principal over a 25-year loan under those conditions. We now turn to the question of how much principal repayment is happening through the loan. We can calculate that indirectly. There's no direct Excel function, or in fact, I'm not aware of a direct financial calculation, financial maths calculation for this. However, it's relatively easy to calculate using the standard functions that we've used, but in a slightly non-standard way, if you like. The principal outstanding at the end of 5 years is really the present value of the number of payments still left in the loan. And so if I'm standing at the end of the 5 years, what it means is that on my 25-year loan, I've got 20 years still to go. And so what I can do is work out the present value. That's using the Excel PV function, which we will use, PV, open brackets. The rate is 1%. Now the number of periods here is 300, which is the number I've calculated above here, minus 12 times 5, or I could have simply put in 60. And then the monthly payments. Again, I'm going to put in a minus number here, and the purpose of that is simply to stick with Excel's conventions for sign. And it's minus D21, close brackets, and that tells me that at the end of 5 years I have a principal still outstanding of $334,000. If I want to calculate how much repayment I've actually made, how much principal have I repaid, I can simply subtract from my original principal the principal at the end of 5 years. And so I've worked out that in 5 years of paying off my loan, I've paid off $15,000. And if you look at that and see that each month I've been repaying about $3,500, so in other words, in about 5 months' time, I have summed up more than that. You can understand why people often say that in the early parts of a loan, you're really paying little more than interest. Now, I'm not going to calculate the principal at the end of 10 years and 15 years. I'd like you to do that yourselves, and also the principal repaid at the end of those 2 periods. I'd like you to get that experience. The challenge for you is to get rid of the yellow highlights. I'm not going to do it for you in this case, but I'm quite sure that if you followed what I've been doing so far, you should be able to put those numbers in without too much difficulty. I'm next going to move to the accelerated repayments. By accelerated repayments, I'm meaning the situation where I've decided to repay my home mortgage a little bit faster by increasing my repayment above the minimum. In this case, the minimum has been worked out to be $3,686 per month, and I'm going to repay it at a 10% higher amount. And so to work out what the higher repayment is, I can simply take the 3,686 and multiply it by, I'm going to open brackets, 1 plus the 10%. Again, I'm writing this as an equation, and that enables me to change my data later on, and the equations will still work, so I'll still get the same correct answers. And so I'm going to pay it off at $4,000 a month rather than $3,600. That might be by choosing not to go to the restaurant quite as often, or maybe give up smoking, or whatever it is you're going to do, maybe catch a bus to work rather than taking a taxi, whatever it takes to save those few $100s. Let's look at what that makes in terms of saving over the life of the loan. To do that, I'm going to first of all work out how many months it's going to take to repay my loan. It's supposed to be 25 years at the standard repayment. I can work out the number of months using the NPER function. NPER, open brackets, still the same basic form. What is the discount rate? 1%. What is the payment? I'll put in minus $4,000 there. What is the PV? What I borrow initially? So it's 350. So see, I'm just pointing and clicking to bringing in the data values. Hit return. And so now, if I pay back the loan 10% more per month than I negotiated with the bank, it turns out instead of 300 months, it's only going to take me 199.88, which is almost 200, which is about a savings of a third of the time. That's nice. That's how many years is that? You can work that out. I'm not going to bother, but I'd like you to get rid of the yellow highlight for the sheer joy of having done it successfully. To work out the total repayment, I can simply say, well, there's going to be $4,000 paid 199.88 times, so total repayment now is $810,000. Again, I'm going to leave this next calculation to you to work out, and it's the overall saving. And I'll simply give you a hint that in the standard repayment, I make a total repayment of $1.1 million. In the accelerated repayment, I only pay back in total $810,000. You work out the equation. That represents the amount of saving by merely increasing the repayment. That is even after you take account of the fact that you are paying more per month. Okay, so it's the net saving. That's the absolute benefit by simply taking this strategy, and you should find that it is a very big proportion of the initial principal. Now, that kind of saving means that the loan is only, in a sense, cost you half as much as it would have otherwise. It's one way of looking at it. You can understand why the banks don't go out of their way to necessarily tell you this, unless they're trying to attract your business from a bank that doesn't, or something. But I recommend that you do those calculations. I'm going to leave you now to work out the remaining yellow highlights here to work out the principals outstanding and the principals repaid. I'm sure you'll be able to do that, and then you'll have this nice little loan calculator, which from what I've seen in the past, people find very handy to have somewhere in their back pocket.